Good afternoon, everyone. It's a good afternoon where we are dwelling into a topic in Book 3, Quantity of Heat. It's a topic known as quantity of heat. And under quantity of heat, we are introduced to definition of terms. And from this paper that we are looking at, this is physics paper 1. So we are defining specific heat capacity, where we say that the specific heat capacity is defined as the quantity of heat required to raise 1 kilogram mass of 1 kilogram of a substance by 1 Kelvin. So the amount of heat energy required to raise the mass or 1 kilogram mass of a substance by 1 Kelvin. So this particular point, it can be 1 Kelvin or it can be 1 degree Celsius. There is no big deal when it comes to this topic where we talk about temperature. So the temperature, but basically we use the temperature just the way they are, either in Kelvin or in degrees Celsius. So we say that the specific heat capacity Q is given as C change in temperature, where M is the mass of the substance, then C is the specific heat capacity, and delta theta, that is the change in temperature. Now C will be given as Q over M change in temperature. I believe that one is okay. Number 2, or part 2 of that question, you are given an experiment here where you are determining the specific capacity of aluminium metal. Now this is the setup that was used, so allow me put it this way so that you can be able to see the full question. Now this is a setup. This is a method that is used to determine the specific heat capacity of a solid, and there are 2 methods. One is the method of mixture, so we have method of mixture, and 2 is the electrical method. Now what we have is the electrical method. Now what are these components? This particular point where we have a thermometer, these are whole. There should be oil, and again here we should have oil as it has been indicated. So A at that particular point is connected across the heater. Therefore our A becomes a voltmeter, because we need to get the voltage across the heater, and B is the ammeter that will be recording the amount of current. So we're going to record the amount of current. Voltmeter, we just need the voltage across the heater. Then we have this data that is provided. We have the voltmeter reading, ammeter reading, the mass of the block, the temperature of the block, the final temperature of the block, and again the time taken to heat. Now using this information, are we able to determine the specific heat capacity of the aluminium block? So we say that the specific heat capacity of the block, we know that energy E equals to VIT from heating effect of an electric current equals to the mass multiply by the specific capacity, multiply by temperature change. So we say VIT equals to MC change in temperature. Therefore, V is given as 2.9 multiplied by current 1.8 amperes is voltage, multiplied by the time 250 seconds equals to the mass is 1.12 kilograms, multiplied by the specific capacity, which we don't know, multiplied by temperature change from 35 to 22. So 35 subtract 22, that gives us the temperature change. So using our calculator, we can basically get that value. We can get this value, so it is easier for us to get that value. So what happens here, so C is given as 2.9 multiplied by 1.8 multiplied by 250 divided by 1.12 multiplied by 35 subtract 22, that gives you 13. So using your calculator you can get that value. So where our bracket, so bracket, then we are saying at that particular point 2.9 multiplied by, that is 1.8 multiplied by 250 divided by 1.12 multiplied by 13. So at that particular point, the answer that we are having, C becomes 89.629. These are joules per kilogram per Kelvin. That's what we have. Then what is the purpose of the oil? We say that the oil around the thermometer and the heater is just to improve thermal contact. And again, there is so what we call uniform heat distribution. That's the next question. Then under the same topic, they are asking us why food cooks faster along the coastline than at a high altitude. Basically, food will cook faster at the coastline where the altitude is lower, and we say that the lower the altitude, the higher the pressure. So the higher the pressure, therefore this one increases the temperatures of the boiling point. Then why is water a better coolant than other liquid? Here we say that water is a better coolant because it has a higher specific heat capacity. It has a higher specific heat capacity. We know that is around 4,200 joules per kilogram per Kelvin. That's why it is a better coolant. Thank you so much, and for more of these questions you can subscribe to my YouTube channel, that is Jumjum or Jumbale Mbarikiwa. Especially Jumbale Mbarikiwa, you can access more of these questions and their possible solutions. Thank you so much, and thank you for watching.